So
I removed it because you're not supposed to do that. It's here on my screen. I can. If you want to see it's the right. We are seeing it now. Right?
Yeah.
We are seeing it, it's not straight lines, right? We are seeing the quality. What is the?
I'll get rid of the entire thing.
I can zoom in. No, I can't. Otherwise, I can zoom in.
Okay. All right. So so we went over the very high level the architecture of the client itself. Now let's look at, I guess. Well, first let's look at how we let the network know that we have stuff stored by our client, right? And there are two modes to this. I'm going to draw a box, which we'll assume is the Codex client itself, right? And then this is the larger client, but let's this is discovery, right? And discovery is DHT, right? So the client does several things, right? So it announces to the DHT that it has some blocks. Provides. It's called provide, right? So the way that we're using the DHT, there are several ways of using the DHT, but in our case, we're using the DHT as a finger table. Okay, and by that I mean that we're not storing actual chunks of the blocks of data, or sorry, we're not storing the actual blocks of data on some address space on the DHT. What we're doing is that we're storing, we're announcing who is having what. So, for example, if I'm holding a chunk with some particular hash, and Leo is holding the same chunk, we will find a node in the DHT that has, that's close to that range, and we will register ourselves as providers for that chunk. So when the node is looking up for chunks on the DHT, what it does is that it finds the closest node to that hash, but then it doesn't get the chunk from that node. What it gets is a list of provider records, and those provider records are the nodes that will potentially hold this chunk for you, right? So this is how we're using the DHT. I mean, I guess it's a relatively important distinction, because it could be, you could use the DHT in a different way, where you just shove the chunk with the hash to the closest node to that hash, instead of using it as a pointer table or a finger table. Okay, so the client, when you upload a data set to the client, or when the client learns of a new block, whatever the way it knows about it, it doesn't matter how it learns about that block. What it does is that it tells the DHT module that it provides this block now, right? And it registers itself with some node in the DHT, providing that block, right? What are blocks in Codex? A block is really any piece of data with a CID, right? So block is any data with a CID, right? And what's a CID? CID stands for content identifier. It again comes from the IPFS sleep P2P world, and it allows you to CID allows you to say what kind of data it's pointing to. What kind? It's important. So why it's important? So this is how we know what we're looking at, right? So there are two types right now. There are two types of blocks in the system. There are manifests and raw blocks. So and raw blocks, right? So what happens when we get a CID? The CID packs. The CID has the type of data it stores, the type of hash that was used to hash that data, and the actual hash of the data, right? So when we look at the CID, we can tell whether we're looking at a manifest file or the hash for a manifest file or a raw block of data. In reality, it could be extended to point to any sort of data, and I'll talk about it in a little bit. We do take advantage of that, or we could take advantage of that because we could encode the type of data that like the manifest itself points to. So for example, manifest could contain the manifest. So yeah, I mean, let's see. I don't want to get ahead of myself here. So let's just stick with this, right? So like, the CID tells you what sort of data you're looking at, which in this case is either a manifest or a raw block. A manifest contains pointers to raw blocks or potentially other manifests. Okay. So back to this picture, when a block gets uploaded, right? So there's a guy saying, I want to upload a file. It sends the file to the client. The client does a bunch of things like chunk it, whatever, right? And then it stores these chunks. Let me write this down here. I think it's for upload. It's important. For upload, it will chunk the incoming stream. Chunk the stream, and then put the chunks, aka blocks, on the store. On the store, and then announce. So this will then trigger a provide call to the DHT with each of the chunk hashes, and it will let the network know that it's providing this chunks for this file that was uploaded here, right? Once the entire file has been uploaded, then we create the manifest file for that for those chunks, and we then take the manifest file, give it another CID, and then we announce that CID as well as a provide record. And then, as you recall, you can tell what type of data you're looking at by looking at the CID. So when you make a request from the DHT, you can readily tell whether you're looking at a manifest file, and you can handle it accordingly, or you're just looking at a block, like a regular block, and handle it accordingly, right? So what happens when you're looking at a manifest file? So let's say that, so this is upload file. Let's say that I want to download a file, right? So let's say that I want to download the file. Right. So what happens is that I make a request over curl, which goes through the HTTP API. It gets to the client, and maybe I draw a different arrow. Maybe that's going to be easier to read if I do it like this. So download a file. I provide a CID in the request, in the HTTP request, right? Then if it's a manifest, then I unpack up, actually I have to download the manifest from the DHT, right? So if it's a manifest, I make a request to the network. But let's say the request goes to the DHT, right? Because we don't know of any node that has it. Right? So the request from DHT, from network, from DHT. So request providers, right? So I say, hey, I need this CID here. Give me all the providers for that CID, right? and immediately there's a response with some providers, and then I proceed to request connect to the nodes that it returned, the DHT returned to me, and I make a request from, I connect to them over loop P2P, and then from then on, the block exchange engine takes over and schedules the download of the block, and et cetera, et cetera. So in this case, we're downloading a manifest block, right? So once we get the manifest block, we obviously deserialize it, unpack it, and we get the block hashes. The block hashes in a manifest, right? Okay, so, and more or less the same thing happens. You can request the providers for each one of the CIDs for each one of the blocks in the manifest, but you could also, assuming that you're already connected to someone that announces the manifest, and assuming that that someone has at least part of the blocks for in that manifest, you would be able to just schedule the download of those CIDs from that node that you've already connected to get the manifest, right? So, and then, yeah, from then on, essentially, the client calls the DHT to notify it that it provides a record, and then it also queries the DHT for provider records for hashes of blocks or manifests or things like that. Is this clear?
Yeah, the only thing I want to ask is, how does the block exchange?
Yes, the block exchange. Yeah.
It's the block exchange announcements.
Yeah. So I'll draw this out in high level again here in a sec. But yeah, so the block exchange has a mechanism to essentially. So okay, so once you've connected to, so the block exchange assumes that you're already connected to the nodes, right? So the block exchange kind of takes over from the part where you've already connected to a node that potentially has the blocks that you want. Okay, so the DHT takes care of everything before that, right? So like the DHT comes into play before you've connected to nodes that have the blocks that you're looking for. Once you've done that, then you're pretty much always interacting with just the block exchange rather than with the.
The block exchange is handling the ID. Well,
Yes.
and the connection, multiple connections.
Yes, exactly. The block exchange handles the connections to the nodes, and it schedules uploads and downloads from those nodes for CIDs that have been requested from it, either internally by like it, calling into the block exchange locally saying, hey, give me this block, in which case we'll try go and call the DHT first, discover nodes that potentially have this block, connect to those nodes, and then exchange lists of ones and halves, right? And from then on, it starts negotiating downloads essentially and scheduling downloads, right? Any questions here, Charles?
I don't have any specific questions.
Are you able to follow along? Is this clear?
Yeah, I think so. I
Okay.
think it's pretty clear.
Okay.
I mean, it's high level.
Sure.
We're not going into
Yeah.
specific. How are the ones and the apps Are those just, are those persistent on disk as well in the object store, or are they just in memory?
Great question.
What's the lifetime of those lists?
Yeah, they're ephemeral. They're in memory. They're not persistent. Yeah. Yeah. So
I don't think I would.
no,
I don't see why we would persist those. It's
I mean, it's a fair question to ask. But yeah, I don't.
Yeah, it depends on how much you're imagining the servers going up and going down and that kind of thing, in terms of whether you want to.
Right. Yeah, no. I mean, like, it could make sense for your local node in case you go down or crash or something like that. But, I mean, we're not doing that. Essentially, yeah, if you were downloading a file and then Codex crashed in the middle, you would have to, you restart the download. But then what happens is that since we first check the local store, those blocks that have been already downloaded, they'll be just, they won't be scheduled to be downloaded again from the block store because they're already, persisted locally. So we are kind of persistent. So the need for persistent the have list or the want list, yeah, we don't need to do that really. Yeah.
But if there's a reboot, are the local blocks re-announced?
Yes. Yeah, that's a good question. So we can take a look at the block exchange and like maybe the stores in a little bit more detail in the block exchange itself. Okay. I'm gonna get rid of this. Sure. Okay. Put that there. Okay, so let's draw the block exchange. Put it here. Okay, so block exchange, and let's put the discovery here as well. All right. Okay, so so the flow of the block exchange is hi. The flow of the block exchange is, I guess, the most important part to understand is that there's the lists, right? So have list, have, and want lists. So what happens on connect when two nodes, this is why it's important to kind of like understand this piece. It's because a lot of these interactions, they're triggered on connect, right? So just by the mere fact of connecting to a node, you initiate a bunch of stuff, right? So you don't have to like connect and then kind of like schedule a bunch of nodes. So the block exchange holds a list of one blocks, right? So blocks that have been scheduled for download somehow. Usually it's done through one of these block stores where we didn't find the block locally, and we say, okay, we need to download this block. What happens is that this block is it's scheduled for download from the block exchange, right? So blocks are scheduled for download. And this is essentially your want list, right? So when you connect to a node, there's blocks that have been that are scheduled for download. They sit in a queue. The queue is read, and all the blocks that are sitting on this queue are serialized in this protobuf, which is called the want list. It's a network message, and on connect, maybe it should be here. On connect, want lists are exchanged. Okay. So on connect, so what happens is that the block exchange gets a bunch of requests for blocks to be downloaded. These blocks are initially, they eventually end up in a queue, right? This scheduling queue. When you connect to a node, the blocks from this queue are, the CIDs for the blocks on this queue are packed into a network message called the want list and sent over the network. Both nodes exchange this. Both nodes exchange this. Both nodes exchange this list on connect. So on connect, you learn of the blocks that the other node wants, and you also send in the blocks that you want, right? And then as a response for the want list, you send it the have list, right? You don't have to send it all the blocks that you have. It might be several hundreds of megabytes of data, but you send it a number of blocks that you have.
So what puzzles me a little bit is that we have information based on the Azure coding structure. We are not using it. We do extra exchanges of I have this, I want that, which the other part could already guess based on the Azure coding. And Azure coding and placement. So it's it's really
I know where you're coming from with this, but I think in this context, it's I have to think about this a little bit more in terms of, like, is this a 1% optimization that's going to take us 80% of effort, or is this like a real optimization that has a potentially very big impact overall, right? So I totally get where you're coming from. Yes, we do know the structure of the data set, we could potentially, without having to send a bunch of that might be a hint of what else needs to be sent back, right?
Yeah,
So,
it can just
yeah.
prioritize what happens.
Exactly. Right. Yeah, but it doesn't have it right now. It's not something we have in there now. It's the block exchange is largely agnostic to the erasure code and the structure of the data set. What's being downloaded, whether it's a raw block or a manifest block or any other sort of block that we might come up in the future. It's largely, it simply optimizes exchanging chunks of information between nodes, essentially, right? So, yeah. So,
I have a quick question.
sure.
Is the idea for the erasure coding to that manifest level? What's the idea for integrating that?
So the erasure coding is at the so the parameters for the erasure coding are stored in the manifest. Yeah. So really the parameters for the erasure coding are in the manifest, but the manifest itself doesn't hold any data besides just the hashes for those blocks. Yeah. 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 Okay. So, okay, is this clear? And from like really, the rest of what the block exchange does, it actually relies on the once and have lists throughout, right? It doesn't have a specific message to give me this specific block. It's the same one message sent, which is, instead of it has a flag on it saying, just let me know if you have it or give me the block, right? So, the messages are largely reused in across the board. And this makes the flow relatively streamlined and relatively, it's not simple, but could have been a lot more involved. Yeah, and that's really all there is to it. If you don't find, so what happens, like where the discovery piece comes in, is that if the nodes that you're already connected to and that you send this want lists to, right? So you send the want lists on connect, and then you keep sending this want lists, let's say periodically when you learn of a new block, right? So if of all the nodes that you're connected to, none of those nodes can tell you that it has the block that you're looking for, then you essentially just request it from the discovery, like schedule. Yeah, you ask the DHT to provide you with potentially new nodes that might have this block. So yeah, the flow is, okay, let me ask all the nodes that I'm connected to if they have the block, and if none of them has it, I'm going to ask the discovery, the DHT, to give me some provider records. I will try to connect to those. Those that I succeed, I will exchange my want lists, and potentially in this want list, the block that I was looking for is going to be part of that list. The have list that I get in response for my want list. And then from then on, I just request the block. Yeah. So this makes the flow really, really like relatively simple. If you look at the way that the file download works, is essentially you have a CID for a manifest, right? Let me actually, I'm going to erase this again. So downloading a file is really I say file, in reality it's just a CID. CID, right? So download file or CID is, the CID has to be a manifest. So get the manifest. Get the manifest. Extract CIDs for blocks from manifest. Then ask the store for the CIDs. By the way, to download the manifest, you also ask the store, right? For the CIDs. The CIDs. Then the store will do if local, if locally available, local CID, then simply return it. Return it. If not, then download from network. So this is really all there is to it. This 1, 2, 3, 4, 5 steps, right? And this is really where the magic happens. Essentially, you ask the store says, oh, I have it. Let me just read it from disk, give it back to you. Oh no, I don't have it. Let me schedule it on the block exchange, and the block exchange will figure out how to get it.
So when it's scheduled on the block exchange, dynamically like that, that then is basically added to its want list, right? But there's no, let's just say it's already got a bunch of connected peers. Will it then cycle through, like live through all its peers and say, hey, I've got this new updated want list, or I've got this one particular SID that I want, do you have it?
Yeah, I want this. I have this one particular seed that I need. Do you have it? You can batch those as well if you want to. You have several. So we don't have this batching mechanism yet. That's an improvement that we need to add. It's just it's a detail. Essentially, you could, instead of sending all the CIDs for like creating a want message for every single CID that you get scheduled after the initial exchange of lists, you can have a task that runs every 500 milliseconds and batches the ones that have been queued in the process and sends them out. So right now it doesn't happen. That's an improvement we made. Yeah. But high level again, this is more like this is the flow, and I guess the so this is the download flow. The upload flow would be the difference. Obviously, it's kind of an inverse flow.
So what would you mean by upload?
Upload. Upload is
Upload.
no. It's upload to your local node. Yeah. Yeah. This is without all the persistence. This is without all the erasure coding. This is without all the other stuff which gets interleaved here, but it's not important for this. Yeah.
On the API side, those we have.
Yeah, so we have upload, download. Essentially, those are the two most important ones. Yeah, so upload, download, you have a connect. So you can explicitly connect to a node. You have find. So you could trigger discovery of a, actually no, if you connect accepts a list of addresses or just a peer ID, and if it doesn't have a list of addresses, it will try to find that peer for you. Yeah, using the DHT again.
Then you have find.
That's the find essentially. So if you do connect, and if you don't provide it with a list of multi-addresses or addresses, it will immediately go to find. Just try to discover that.
And download is what are the parameters of download?
Just the CID.
And that's assumed to be a
Yes, that's assumed to be a manifest. If you, okay, so here's what happens. If you give it just a block CID, it'll just download the block. If it's, yeah. If, yeah, it's also agnostic to what kind of CID you're giving it. It's just, it's gonna, if it's a manifest CID, it'll try to unpack the CID and schedule the blocks contained within the CID. If it's just a raw block CID, it'll try to download that raw block CID for you. I think one useful method that we could add is to the ability to extract a manifest. So you have like a manifest file, and then yeah, exactly. Yeah, and yeah, so like you can extract and save it yourself, and then you can you have another method which accepts a compressed manifest file, and you can initiate a download that way from the manifest file.
So for the initial coding,
Mhm.
you download, which is just downloading
No, so what happens with the erasure code, and it's partly there, is you, well, first of all, the erasure coding works. How do you go from a data set that you've uploaded to an erasure coded data set? So there's an endpoint that you call and pass it the data set, the CID of the data set that you want to erasure code. It will, again, that part is transparent. It actually might download that data set for you, or if it's assumed that you have it locally, but it's not required. So it will take that original data set, erasure code it, and give you back a new CID for the erasure coded data set.
It's and then I take the initial coding. But if I would like to take a nice like if a node would that on the concept and then out of the but you need to I need those chunks.
Yeah. So you don't do it from you do it. So what happens with since you already have the block exchange mechanism available to you, you simply say, okay, well, these are the blocks I'm going to be storing. Let me just schedule them. Like, let me just ask them from the block exchange, and I'll download it from the block exchange.
How do you get those? You would need something like a spot ID.
Yeah, I mean, so you need to have the manifest, and you need to know some parameters that will allow you to derive the blocks that you need. Yeah.
Yeah, and then
Yeah.
exchanges.
Yeah. Yeah.
I don't think we have that part.
No, we don't have that. There's not, like, we don't need to do anything else on the client side to support that. We just need the marketplace to be able to determine what the range of this blocks it needs, and then just take the array of blocks from the manifest and say, I need every third block, I need every 10th block.
Yeah, what I'm saying is if we have the, then even if we don't have yet the marketplace, manually single takes what comes.
We could add that as a debug method, like just like purely for debugging if you wanted to, or like testing. But really, from the standpoint of the client, like nothing. There's no specific mechanism for that. It's just saying, just give me this list of blocks. That's it. Sorry.
Wouldn't the marketplace then have to be aware of the distribution parameters? Like, you know what I mean? Like, it's sort of like an algorithm. My mind, the way I see it is like it's part of an algorithm on the client end. There's a distribution. And as you said, like slot index or something like that. How you figure out what inputs you have to distribute data, what is the ratio coded, and then it never gets distributed. So, the host.
You don't need to distribute it. You as a client just need to know which pieces you need to download. That's it, right? So, and those are going to be both the erasure coded pieces and the non-erasure coded pieces. And then the block selection mechanism in the marketplace will have to be coded in a way that it selects blocks in a determined way that yeah.
I will look in the marketplace. So at the marketplace, I believe that the abstract stock levels, so I'm responsible for that stock.
So the marketplace, yes, that's going to be in the client. The marketplace has triggers and parameters, and the client will have the logic that will determine which blocks to select from the manifest.
Yes, it's
Yes.
the logic of both for understanding what stock means, and then also when downloading, handling the eligible.
Yeah.
So if I have this quantity, I don't need those four because it's not really enough.
The client only has the, I don't know, like the parameters. Maybe it has its position and like what slot it's selected, and then the client knows which blocks needs to be selected according to some algorithm that we've provided with. Yeah. So, like all the Lego pieces for all of this is in place. There's really, it's just getting them hooked in. If you guys get the marketplace kind of like, if we get all the plugin points in place and all of that, then we can trigger that part. I mean, we can do what Chava is saying, where we can just say, hey, give me, like, for our own debugging purposes, we have an endpoint that says, my slot position is this, and then that triggers download of selection of blocks. Yeah.
And this is my slot position. Get everything.
Yeah.
Like needs to be an algorithm, and that would be in the marketplace on the client.
Yeah. That's definitely in where the trigger for like where that event is. Yeah.
We have a lot of human repair or repair situation or filling the slot. Effectively, go down to filling the slot whether it's repair or not. But I'd say like if you fill a slot, like, you need to download it. So when you repair it, it's repair, slot's free.
Hey, just having the ability that allows us to make much more.
Yeah, I mean, we have an event contract event that says the slots are free. So I guess there needs to be some logic, some way to figure out that a slot is available. So yeah, I think there's a way to pretty much poll this main contract and figure out when new requests have been created, or actually, sorry, there's an event for that too. Contract that says request been created, there's this many slots. That's all, it's all sort of. Each contract event is that sort of signal.
Yeah, I mean, I think at the contract level, it can also be relatively agnostic. We can use pretty much this. I mean, it's going to be the same logic, exactly the same logic. Right? So rebuild isn't that much different than downloading the entire data set. Yeah. So rebuild is, again, just knowing which so the way I imagine this, like we already have an erasure coding module, right? So like it already has the rebuild logic built in. So as long as you provide, like as long as it knows what the geometry of the data set is, it will already trigger rebuild of blocks as soon as it gets enough blocks for that row or column.
In the build is once you build it, you should know what to do with it.
Sorry?
Once you rebuild a part of the you need to know what you want to do. There are some parts which you want to resist because you are responsible for them. Others might go into local cache as the environment store them. So later you might store them. This kind of logic.
That's really simple. So what we have is that blocks that are going to be persisted, when you do store block, it's got a flag that says persist. Yeah, I mean, because yeah, that's it. I mean, maybe it has a DTL of some sort, but like you don't do anything with blocks that are persisted.
So when we are testing, like just is testing.
Who your should be like have the. Yeah,
I mean, okay, yeah,
I was just curious.
sure. Oh, and he left this thing here. Nice.
Yes.
How do I unhook this? Oh shit! I don't want to break it.